All right, hello linear algebra students. Welcome to our first video in the online coronavirus version of linear algebra. Our first section is going to be the introduction to determinants. We've already mentioned this word determinant. It showed up when we were finding inverses, and we're going to take that idea and build on it, talk about how to find determinants of larger and larger matrices today. The big thing we're going to learn something interesting about determinants, not just how to find them, but what they mean, and that's going to be the next lesson that we discuss, the next couple of lessons. But just to kind of tell you in advance what it is, determinant for us is always going to be connected to the idea of volume or area, and how an area or volume changes as you move from one set of coordinates to a different set of coordinates. And so determinants are somehow measures of area and volume. So anytime you see a determinant just magically show up in another class, differential equations, this happens. In Calculus 3, this happens. When you see the determinant just magically show up, what it's actually doing is it's actually calculating an area from one set of coordinates to another. For example, you'll find that whenever you're doing change of bases in Calc 3, when you're doing integrals, we have to always use a determinant in that. And the reason is because integrals measure area, and so if you want to change your variables in Calc 3, then you also have to account for how did that change of variables change the area of your new problem. So that's why you need a determinant to show up. Okay, well, just a quick disclaimer. You all know, you've had me in class enough. I make mistakes sometimes. I will stutter and say and ah and things like that. And I will just write the wrong thing or say the wrong thing. What I would love to do would be to go back on these videos and edit them all and make them professional, where anybody could watch them and they'd be perfect. But it turns out we just don't have the time or resources to do that this semester. I'm just going to do these just like we're in class, and so I'm going to make all the same mistakes and say all the wrong things and stutter just like I would if we were in class. And I just ask that you all show me a little bit of grace in this. And when I say something wrong, just kind of yell at your screen, just go, Dr. Fisher, you're wrong. And it won't make any difference, but at least you'll feel better about it. Okay, so that being said, let's talk a little bit about determinants. When we have a matrix A, the notation we're going to use to describe determinant is we're going to put a little absolute values on here. It's not absolute values, it's determinant, but when we put those bars, like the absolute value bars, on a matrix, we actually mean determinant. It's actually not magical that they're kind of the same type of notation, because in some ways absolute value is a measure of size of a number. So if you have the number -5, that the size of -5 is 5, because that's how big it is relative to the origin 0. And remember, we also used absolute values when we talked about the size of vectors and the magnitude of vectors in Calc 3 or in physics or in other classes. So this thing's giving us some measure of magnitude, and so determinant is some measure of the magnitude of the matrix. It's a measure of how big or how much volume or how much area this matrix is representing. So it's not a surprise that we could use this notation. Okay, so let's just talk a little bit. Let's go to the determinant problems that we've already done. So we've already done one that's pretty simple, and let's solve this first problem on here, the problem 2, 4, -1, 3. And so if we have this determinant, what you found was that we just took these two and multiplied them together, and then we took these two and multiplied them together. And so our answer was 2 times 3 minus 4 times -1. And so when we had our formula before, it was AD minus BC. And so we had these numbers here, and so this ends up being 6 plus 4, and so 10 is what we get for this determinant. What we're going to do is we're going to try to make an iterative method for thinking of complicated problems in terms of a bunch of smaller problems. So when we get a big determinant, a 4 by 4, even a 5 by 5, what we'll do is, instead of thinking of it as a huge determinant, we'll think of it as made up of a bunch of smaller pieces, and we'll piece all those smaller pieces together. And in some ways, this problem itself can be thought of as a collection of smaller pieces. And so it is the number 2, 4 negative 1, and 3. And what it can be thought of is this number times the determinant of this simple matrix right here minus, so it can be thought of this number 2 times the determinant of what's left with that matrix that just has a 3 in it. And of course, a matrix with only one number, the determinant is just the numbers that shows up. And then the other one is going to be this times the matrix of that number. And so we're going to have 4 times the determinant of the matrix that has just the 1. So here, let's put absolute values on that so we can kind of see. And then we're going to do one more funny thing, and that is we're not going to just add all these numbers. We're going to do a plus and a minus sign. We're going to have to switch our plus and minus signs. We'll talk a little bit about how we switch plus and minus signs, but hopefully this will make sense. But if you think of this iterative way, this is going to be the blueprint for thinking about further problems. We'll move ourselves across the row. So we'll move ourselves across this first row just like that, and we'll do that one times the determinant here, that one times the determinant here, and plus and minus. Okay, so let's come over and let's tackle the next problem. So our next problem is a 3 by 3, and we're going to do the exact same thing that I mentioned just a second ago. We're just going to move across that first row, and we're going to tackle it as the number times the determinant of what's left over. So if we look at this very first one, we've got the number 2, and then we've got a matrix right here. So we're going to have 2, so we're going to get 2 times, let's write determinant, let's put the bars on it, 2, 4, negative 1, 3. So it's 2 times the determinant of that matrix. Now what I'm going to do is I'm going to move over to my next number, and this is where we have to be a little bit creative, but we're going to be just fine. So now I'm going to take my next number, which is this one, and now I have to look, well, what's my leftover matrix if I'm using negative 1? It's not as obvious as it was in that first problem. But my leftover matrix is actually the matrix that's made up of this part and this part when we glue them together. My leftover matrix is the matrix 0, 4, negative 2, and 3. So that's the leftover matrix in that problem. How do you kind of know what the remaining matrix is? Well, you take the point you're looking at, and then you kind of block out in your mind the row and the column that it's on. So it's like we have this point, and so we blocked out that row, blocked out that column, and then we take the determinant of everything left once we've deleted that row and that column. Okay, so we've deleted that row and that column, and then we get it. And finally, we're going to have, it's a negative 3. And then the matrix that's left over, here, I'll just use another color here. So we've got negative 3, which is right here. We'll block out that row, block out that column, and what you can see is that the leftover matrix is that part right there. And so our leftover matrix is 0, 2, negative 2, and negative 1. Okay, so these are our parts. Now, what you'll remember is that we have to combine these. We couldn't simply add them. Last time we had to add and subtract, and this time we're going to do the same policy. We're going to add and then subtract and then add again. So we'll do plus, minus, plus. So do plus, minus, plus, and this will give us our answer. So we've got 2 times this determinant I did earlier. Notice this is 6. If I look at that diagonal, that's negative 4. And so this ends up being 10. So 2 times 10 is what we get. Minus negative 1 times this diagonal is 0. This diagonal is negative 8. To do the diagonals, I'm just multiplying along the diagonal, just like we did earlier. And so this is negative 1 times a negative 8. And then finally, negative 3. And then what's left over here, we've got a 0 and a negative 4. So this ends up being 0 minus negative 4. And so this is a positive 4. Oh, this one should have been a positive 8. I wonder if you all caught me there or not. Did any of you yell at your screens? If so, well done. Now your family all thinks you're crazy. Okay, so we've got 0 times 0 minus negative 8. So you always take this diagonal minus that diagonal, and we get positive 8. Okay, so we put all these together. I'm running out of board space, but that's okay. So it looks like our answer here. I got plenty of boards. Why am I conserving boards here? Okay, so what's our answer? Our answer is now 20 plus 8 minus 12, and I believe that gives us 16 as our answer. Okay, so 16 is the determinant that we get when we do this problem. Okay, I want to do this problem again because why would we do a problem just once, right? So let's do the problem again because I want to show you that there are other ways we can think of the same problem, and if we're clever about the way we go about it, then if we're clever about the way we go about it, sometimes we can make our problem a little bit easier. So let me write down the problem again. 2, -1, -3, and then 0, 2, and 4, and then -2, -1, and 3. So I believe those are correct numbers. Now, last time we decided to go across the top row. Well, there's actually nothing magical about the top row. We could choose any row or even any column. And if you choose any row or any column and you go along it and do the determinants of what's left over, the problem still works just fine. And as I look through, I see one row that's going to make my problem simpler. It's going to give me less computation. And it's actually this row right here. Because notice, if I follow this row, then all of a sudden I'm multiplying by a 0. And 0 is the best number to multiply by, right? Because it just makes everything 0. So let's follow this row and see what we get. So this time I'm going to get 0 times, well, now what's left over after I choose this number 0? So let's choose this number 0. And then that means we have to block out this part, block out this part. And what you see is left over is that part, and that part's left over. So my leftover determinant is -1, -3, -1, +3. Of course, it actually didn't matter what those numbers were because we're multiplying by 0. So we would have got 0 no matter what. But I wanted to take the time to think about what would happen if we chose a different spot. Okay, let's, okay, I'm killing it here. Okay, not in a good way. Okay, so now we've got 0, 2, and 4. Now let's move across our row. So we're going this direction. We're going this direction in our row. So let's move across and pick our next number. Our next number is going to be that 2. So we're going to take 2 times a determinant. And what's left over for that determinant? Well, notice if I block out the row, block out the column, what I'm left with are just these 4 corners. So the matrix that I'm left with after I blot out the row, blot out the column, is the matrix 2, -3, -2, and +3. Okay, finally, we're going to do this 4, and tell you what, I'm not going to go through all the details because I think you all are clever enough to keep up with me at this point. So we've got 4, and then we've got 2, -1, -2, and +1. And there we go. Now, the last question is, how do we do the plus minus plus thing that we did earlier? Well, it turns out we have to make a small adjustment. And the adjustment, the way we're going to make an adjustment is we're going to make a matrix. We're going to make a matrix of plus and negative signs. And it's just going to look like a checkerboard. We're going to start with a plus in that corner, then go to a minus, and then go to a plus, and then go to a minus, plus, minus, plus, minus, plus. I'll just mention in passing next time, we're going to skip some of the proof stuff that goes into why the determinants work the way they do. Just because we're on a condensed schedule, you're learning from home, so we're going to have to lose a little bit of what we normally do. So let me just give you a quick reason why this might be what we do. So if you think, if we wanted to switch this matrix, we could do row reduction and switch the top and the bottom rows. But it turns out every time you switch rows in a row reduction, it changes the sign of the matrix. Every time you switch 2 rows that are next to each other. So it changes the sign from positive determinant to the negative determinant. And so if you imagine, if we wanted to make that number in the corner, we don't have to do anything. And so it's positive. If we want to put that number in the corner, we would have to switch 2 columns, and that would add a negative to our problem. If we wanted to switch, say, that one to that corner, we'd have to switch a column, switch a row, and switch another row. And so it'd be 1, 2, 3 switches, and so that would make it negative, whatever the result was. So you're really just counting how many switches it would take to get to that upper left-hand corner. But okay, at any rate, you don't have to remember all that. All you can remember is draw the checkerboard. We chose this second column, and so we'll choose the second column of the checkerboard, and that means we'll go minus, plus, minus, and that's how we'll get our answer. Okay, now let's start to calculate. This first number is the easiest one we'll do all day. It's 0. Okay, the second number is 2 times, and now I have to do a little bit of computing. But notice here I've got 6 and a positive 6. So what is 6 minus 6? It is also 0. Wow, that came out to be nice. And now we'll do minus 4 times, and now we just have to do this last part. Let's see what we've got. I've got 2, positive 2, and then positive, wait, hold on, I got a sign wrong here, didn't I? Let's see, 2, negative 1, negative 2. Oh, that's a negative 1 also, isn't it? So that makes this a negative 2, and that makes that a positive 2, so that's a negative 4. Okay, now if we look closely, what you'll see is that we've got, if you look closely, what you'll see is that you've got negative 4 times negative 4, 0 plus, oh, that was a 0. I said 0, didn't I? I think I just wrote the wrong number down. 0, 0, and then positive 16. So we get 16, which is the same answer we got before. It should be the same answer we got before because that's the way math works. If you solve the same problem more than one way, hopefully you get equivalent answers. All right. Let's jump to the next problem, and this is a spot where it's really good to pause real quick. So here I'll put the little pause symbol on my board. So it's good for you to just pause your video for a second, try this problem at home, see if you can get the right answer, and then come back and check with me. And that will that way you'll know if things are working well. Okay, so pause, go try your answer, and come back. All right, hopefully you did that. Hopefully you did pause. If you didn't, well, shame on you. You should be ashamed of yourself. No, it's fine if you don't, but it'll be better for you. The more you try things on your own, and then try to work with me, the better you're going to stay on top of everything. Okay, so if I look through this, you can actually choose any row or any column, but if you're like me and you look through the problem, there's one row and one column that makes the most sense, isn't it? And that is this second row is just crying out, please use me, please use me. And why is it crying out? Because it's got 2 zeros. So that means we're going to have 0 times something and 0 times something. So this is going to end up being a pretty simple determinant when we're all done. So my answer that I get is going to be 0 times a determinant. And you know what? We could figure these numbers out. It looks like the numbers are negative 4, 5, negative 5, negative 3. But notice, it actually doesn't matter what those numbers are. Okay, and then our next one is going to be 0 times, tell you what, let's just put some dots here because it doesn't matter what those numbers are. And then finally we'll have 2. The 2 is the one I have to think about because it matters. So if I take this 2, then that wipes out that row and that column, and I'm left with what's left over, and I've got negative 1, negative 4, 1, negative 5. And now I just have to ask myself the question, and the question is how did the plus and minus signs go? And so let's draw that plus and minus checkerboard again. Uh-oh, that's not a checkerboard. Let's draw the plus and minus checkerboard. We're doing that second row, so I'm going to do minus, plus, and minus. And so that means this final answer, I've got 0 plus 0, and then finally I've got minus 2 times, and now I have to figure out this determinant. This determinant is a positive 5 minus negative 4. So I've got 5 minus negative 4. So what did this come out to be? 5 minus negative 4 is positive 9, so it looks like negative 18 is what we get for our answer. And by the way, in case you're curious, you may have already figured this out. I mean, your calculator can do this. So let's do it on our calculator real quick, and we'll see. So if I put my calculator up here where you can see it, what do? You go to Matrix, we go to Edit, we put our numbers in here. So let's do negative 1, negative 4, 5, 0, 0, 2, 1, negative 5, negative 3. And then I'll quit out, and then I'll just go Matrix, and then Math, and then you can see the determinant. So sometimes we're using those little vertical bars, but a lot of people write DET instead of the vertical bars, and that means determinant, and they're equivalent notations. So we'll do determinant. We'll go pick the correct matrix. So we want A, determinant of A, and hit enter, and we get -18. Hey, good, that's our answer. As I've told you all before, I don't want you all, I mean, we could teach anybody. I could teach my 7-year-old how to type numbers in a calculator and hit the determinant button. What I want you all to do is I want you all to understand what your calculator is doing. I want you to have a deeper level of understanding than your calculator. All right, let's jump over and try our first 4x4 problem. So again, this would be a good time for you to try it yourself. And so pause it here and try it out. How's the 4x4 going to work? If you're not sure, that's fine. But if you think you have an idea, go for it. Okay, pause. All right, I'm glad you're back. I hope you paused it. If not, I hope that you at least have been thinking about the question of how should a 4x4 work? And the answer is the 4x4 works just like the 3x3 in that you pick a row and you start moving across it. So for example, we could have picked this row right here, and then what we'd have done is we've taken the number 1 times the determinant of what's left over. So it'd be a times determinant of -1, 3, 0, 0, 2, 0, -3, 1, 0. And then how do you do this determinant? Well, to do this determinant, you have to then break it up. So you have to follow a row on this one and do the determinants of the different parts of that one. So basically, the bigger your matrix gets, the more steps you're going to have, but it all looks just like what we did. You move systematically across a row, and then each time you move, you take that coefficient times the determinant of a smaller matrix, and then you might take that coefficient times the determinant of a smaller matrix until you finally get down to the answer that you're looking for. Okay, so as I look at this problem, there are a couple different ways we could do it. I'll tell you that when I look at this problem, there's one part that's screaming out to me, hey, use me for your determinant, and that is this last column right here. So I told you earlier we could use rows or columns. By the way, using row 2 isn't bad. You get 2 zeros here. Row 3 gives you 2 zeros, so those are both pretty reasonable calculations. But when I look, I'm like, ooh, look at this column. This column says use me, because then you get 3 zeros and all you have is one number left over. So let's do that one. And so as I do that one, I've got 4 times the determinant of 0, -1, 3, 1, 0, 2, 4, -3, 1. And then I've got 0 times a determinant, 0 times a determinant, and 0 times a determinant. And I'm not even going to write what's in those determinants because it doesn't matter, right? Because they could be anything. And it would be 0 times that. Now the last question that I have to ask myself, you always have to ask myself, are these positive or negative? And to do that, I draw my checkerboard. And now the checkerboard just has one extra point in it. And we are in the last column, so we're using this last column of the checkerboard. So we've got minus, plus, minus, plus. Of course, the pluses and minuses don't matter with the zeros, but if they did, we would make the second term positive, the third term negative, the fourth term positive, because we would follow this pattern right here. Okay, so now we're in really good shape. All we have to do now is calculate the determinant of this thing. And how are we going to calculate the determinant of this thing? Well, I'm going to do the same thing. I'm going to pick a row or column and go for it. And why don't we I guess we could pick the top row. It looks pretty good. It's got a 0 in it. I guess we do have a negative, but so you could pick the second row if you like. It doesn't really matter. So I'm going to pick that first row, and we're going to do -4 times, and now I'm going to open parentheses, and then we have to do each one. So it's going to be 0 times the determinant of 0 to -3, 1, and then -1 times the determinant of 1, 2, 4, 1, and then 3 times the determinant of 1, 0, 4, -3. And as I look, I have to go, well, are these positive, negatives, or zeros? And we know that our problem goes positive, negative, positive. So that means this is positive. I subtract that number, and then I add that number. So you always have to kind of ask yourself, what are our positive, negatives, and positives as we go through? Okay, so now now as I'm working, I'm starting to scroll some stuff off the screen, but you all will be patient with me. And then now this is 0, so that was pretty easy. That's just going to be 1 times this determinant, so I need to calculate this out. We've got 1 and 8, so it looks like we've got 1 minus 8, so it looks like I've got a -7 in here. And then my last one is, let's look at that, I've got a -3 and a 0, so I've got -3 minus 0, so I've got 3 times a -3. And then as I calculate this out, looks like I've got -4 times -7 minus 9, so -16. And so I've got 2 negatives, so it looks like I've got 16 times 4, which is 64, which happens to be the number of teams that would be playing in the NCAA tournament if it were to happen this year. Okay, hope that didn't bum you out if there are any college basketball fans. Maybe someday we'll have sports again in our life. All right. Finally, let me just say a quick word as we end this. One reason why we might want diagonal matrices, and what you'll find is, triangular matrices. Remember, we learned how to make lower triangular and upper triangular. We did some decompositions. One reason you might want a triangular matrix is the determinant is super, super easy. Because notice, what if I were to do this problem? Well, I would just start with this first column, and I would end up with 4 times the determinant of 2, 4, -3, 0, -1, 3, 0, 0, 3. And then what I would do, and notice the rest of these are all 0. So everything else is 0 that goes onto this problem. So what I might do next is I might now take this first column, which now gives me 2 times 4. So I've got 4 times 2 times the determinant of -1, 3, 0, 3. And now notice these two numbers end up being -3 and 0. How about -1 times 3 and 0? And so what did I get from my final answer? My final answer was, let's stick with this red. I kind of like the red color. My final answer was 4 times 2 times -1 times 3. So we put all that together. Looks like we get -24, I think, if I did that right. But notice what did we do? To do a triangular matrix, it's a lot easier than all the other matrices because all we have to do is just look down this diagonal, because every time, every other determinant that you get are zeros, and you only get the determinant of the things on the diagonal. So triangular matrices end up being really nice. It's just 4 times 2 times -3 times -1 times 3. So if you ever get a triangular matrix and you're asked to do the determinant, congratulations, that problem ended up really simple. Well, there we go. You all need to try these homework problems. I'm going to have a quiz that I'm going to post online, and you should try the quiz, and when you're done with it, you should send it to me. I'll put a place for you to put it online. You could email it to me if you can't figure out how to use the online stuff. And by the way, I know some of you may have a scanner or may do it on digitally and send it to me. If you want to do it on a piece of paper and take a picture with your phone, that's perfectly fine also. Just kind of have some way of letting me see it, see that you did the work. All right, so I'll look forward to seeing you in study hall hours, and we'll talk about some more things again tomorrow.